everyone, and welcome back to today we're going to be learning about quadratic functions. So let's begin. So a quadratic function is a nonlinear function that can be written in the standard form of ax squared plus bx plus c. And basically a does not equal 0. So in fancy words, a quadratic function is basically this. It's standard form, but it's a little different. Instead of being a plus b equals c, it is ax squared plus bx plus c. And then again, this a can never equal 0. And for the reason for that is that a quadratic function looks like a u. Fancy word is parabola, but basically quadratic functions look like a u. It might look like a u like this, or it might look like a backwards u. But regardless of it, it will always look like a u. And for the reason that it looks like a u is because of this special part in our standard form. So if this equals 0, then it can no longer look like a u, which doesn't make it a quadratic function. So that's why we particularly say that a cannot equal 0. But anyway, now that we have sort of covered that, we're going to touch on 3 key words that are going to be sort of dominant throughout the video. First is vertex. So vertex is a minimum or maximum point of the parabola. This is a parabola, or our U-shaped thing, but this is a parabola. But anyway, a parabola has a minimum or maximum point. Minimum is the lowest point of the parabola, and maximum is the highest point. So we can see here that in this case, it is the maximum point, right? Because, this is here, and then it's just sort of like going downwards. So this is the maximum point. So in this case, the vertex would be like 0, blah, 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 and this is the maximum point of the parabola. So now we've covered vertex. Let's move on to axis of symmetry. So basically, axis of symmetry, all it's saying is wherever the vertex is, that's sort of the axis of symmetry. And what axis of symmetry means is that whenever you fold the parabola in half, it would be equal. Like it would fold perfectly. It would be symmetrical. And that's the word where we got axis of symmetry. So basically, right, so where are we going to fold? We're going to fold here with the vertex. And when we fold in the vertex, if we fold this part, then it would align perfectly with that part. So here in this case, our axis of symmetry, look at our x-axis, and that's 0. So x would equal 0. It doesn't always have to equal 0, but in this special case, it is 0. And then roots is another word for x-intercepts. And roots is saying is whenever a parabola touches the x-axis, it's a root. So this would be a root. And what other point touches the x-axis? This one. So these two would be roots. So this is just a little gist of it. We're going to move on to a more specific example. Coordinates, and like an actual equation. So here we have, basically I put in a graphing calculator, this function right here. It's x to the power 2 plus ax plus 15. So before we even begin finding the roots and vertex, let's just maybe take the time to write the a, the b, and the c. So we can see that a would be 1. There is nothing in front of the x to the power of 2, which means, as I said in many of my videos, an imaginary 1. B is 8x, so that would mean B is 8, and C is 15, plus 15. So that's it for our A, B, and C. So this is going to be helpful when finding the axis of symmetry, but right now that's not our biggest tension. Right now we want to find the vertex. So as I mentioned, vertex is basically a minimum or maximum point of the parabola. The minimum is the lowest point and the maximum is highest point. So when we look at this graph and we see that there's one point sticking out, it would be this one, right? So is this point in the low part of the graph, high part of the graph, and are all the values above the vertex or are all the values below the vertex? We can see that all the values are above the vertex and that the vertex is at its lowest point, meaning that it is a minimum vertex. And to be more specific, our vertex is, let me just erase this for a moment, it's -4, -1. So that is my point. -4 and -1 is my vertex. I'll just plot it right here. So that's my vertex. So we can see all the values here. Then we have our axis of symmetry. It's the point where that point, if I fold the parabola in half, then it would result in 2 equal parts, or it would be symmetrical and it would line up perfectly. So our axis of symmetry is, yes, I could maybe try to find that perfect point, but there is a formula for that axis of symmetry. And that formula is -b divided by 2a. So for example, b is 8. So I'd put 8, but this negative part means to make it opposite, right? So it would be negative. If it was already -8, then this minus would say to make it positive. But for this example, -b, so that would be -8. Divided by 2 times a. So our a is 1, so 2 times 1 is 2. 2 times 1 is 2. So -8 divided by 2 is -4. And again, so now I would draw that dashed line at -4. And again, you could see that you don't even need to do this formula because the axis of symmetry is your x part of your vertex. But I mean, this is a nice way to double check with -b divided by 2a. So now the last part is identifying the roots. So remember that the roots are the coordinates that lie on the x-axis. And the x-axis is pretty much this. So basically, all what the roots is saying is what coordinates touch this x-axis. We can see that -5 and -3 touch this line. So our roots would be, which we typically put in parentheses, -5 and 3. So yeah, that's it for today's video. I hope you enjoyed. Next video, I'm pretty sure we're just continuing onwards with quadratic functions and learning about vertex form. So see y'all next time. Bye.